Hello everyone. Today we are continuing developing the game in Rust, and today we're going to start looking at Vulkan. So I will be following more or less the Vulkan tutorial page, which I heard is pretty good. So yeah, I will be using this as a reference and also the Vulkan specification and try to learn how to make a Vulkan application. So far we have created a program that opens a window using X11. Here we establish the connection with the X server. We create a simple window. We set the window name. We choose which events do we want to listen for, and then we map the window and we enter into the main loop. So if I run this, we have a simple window, and we were even drawing a small rectangle. I'm going to remove that code for now, and when I press escape, then the application quits. So let me get rid of I'm going to define a constant. This is going to be 264. In fact, for the background, yeah, we need a U64. So we can change the background color on the top of the file instead of having to modify here in the create window function. And then we are going to comment out this. This part of the code, so we no longer draw the rectangle. Yeah, and now we just have a black window. So let's start with the Vulkan tutorial and see. We're going to try to draw a triangle first. The step 1 is create a Vulkan instance, and then we can query support for and select one or more physical devices. Then we create the logical device. Then we have the Vulkan surface and swap chain to interact with the window. And then we get some image views and frame buffers. We create the render passes and the graphics pipeline. And then we can create a command pool and record commands into a command buffer and kick off the main loop. Okay. So, okay. Let's go to the next page. This is on setup. I think do I have Vulkan installed? do I have this directory? I have Vulkan Intel and also the NVIDIA implementation, because this laptop has two graphic cards, the integrated one in the CPU and also a dedicated graphic cards, which is an NVIDIA JTX 6 something, I don't remember now. So do we have Vulkan info? No, we don't have Vulkan info. So how do we install it? Vulkan tools. And here we get a list of the characteristics of Vulkan, I think. How many physical device memory types do we have? How many Q family properties? The extensions that we have available, and so on. I saw an error at the top. So maybe if I type this into less. I don't see it. But yeah, what I was saying, this laptop has two GPUs. This Intel HD graphics, which is integrated with the CPU, and also an NVIDIA GeForce GTX 960. Okay. I keep seeing so we get this weird error. I'm gonna Google for that. And this is for the Intel library. Maybe we need to install something else. I'm going to update my system. Maybe I have something that is not up to date. Vulkan, ICD loaders. And if that doesn't solve it, I'm going to ignore the error for now. Let's read a little bit more. So I think I already have these packages, Vulkan Intel and NVIDIA utils. taking a while. So in the meanwhile, let's take a look. Okay, here they are using GLFW to create the window, but we are using X11, so we will have to convert this. Okay, so this is done. Let's try to see if we have installed Vulkan Intel and NVIDIA utils. I think they are already installed. Okay, we are still having the error, but let's continue anyway. So what we need to do is enumerate the extensions. I'm going to do it at the top before we open the window. So we are going to have an extension count, and then we are going to call this bk enumerate instance extension properties. We pass in null pointer and the extension count. So let's look at this function in the specification. Let's see if I can find it. It's a huge PDF, so it's a bit slow. Okay, so here we have the function signature, and we're going to have to create bindings for all these functions. I will do it manually because it's a learning exercise for me to see how to use C libraries from Rust. So I will start by creating a new module, Vulkan RS, and then I will create a new extern block and declare this function. We take I'm going to use the same casing conversion, since these are bindings for an existing library. And then we also have a pointer to U32 that we receive back as an output. And then we also have the properties, which is a pointer to bk extension properties. And we return bk result. So we need to declare this module in our library, and we can also use everything inside of it. So now we need to define some of the types because if I cargo check this, we get a few types not defined. So we need to define bk result and bk extension properties because they don't exist. So for that, I'm going to actually I'm going to try to find where do we declare the bk result type. Maybe it's a typef. Yeah, it's declared as an enum. So yeah, we can directly create it. Bk result, and we're going to add a wrapper C to make sure that it's compatible with C. And I think we can also add an indication that this is a 932. Let's add a couple. We cannot use reprc and repr i32 together, it seems. So again, we get a ton of warnings about the camel case thing. So let's try to silence those. Now we just get an error that bk extension properties is not defined. Let's try to define a stub for it. So we're going to have an empty struct. They don't have an issue. We also get a warning that extension properties is not FFI safe because it doesn't have any field, but we will add them later on. Okay. Okay, so here it puts together in the same. So maybe this works. No. Okay, so for now I will get rid, and then we need to, maybe I can create a test modules and assert that the size of bk result is the same as an i32, but I won't do that for now. Okay, so let's continue. Let's try to define this. Okay, so the extension properties has an extension name, which is an array of chars, or I8 in Rust. And the spec version, which is a U32. So now we need to define this constant. It's defined as 256. So let's put constants on top of all the structs. So does it check out now? Now we are getting a few warnings, but I don't think we don't get any error. Let's try to silence these warnings. So we want to allow non-snake case types. And now we don't get any errors, so let's go back to our main and call this with standard pointer null. Then a mutable reference to the extension count, and this is automatically converted to a mutable pointer, I think. And then I think we need a null pointer for the last parameter. Okay, and I'm going to use standard pointer so we can simplify a little bit these two. And on top of that, I'm going to try to print the extension count. And see if that works. I'm going to also exit early, and I'm going to import also standard process. and use it. So cargo run, and we get add-on linking error. So I think we need to specify what are we linking with. Was it something like this? I think. Yeah. I think it's Vulkan. And now, okay, we get a warning about unreachable code, which is fine, but we get 19 extensions. Nice. So we managed to call our first Vulkan function, and it's linking properly. So very nice. Let's see what's next. Yeah, we don't need to do all of this. Okay. Yeah, here it mentions that we can install Vulkan devel package. So let's make sure that I have that package installed. Yeah, I don't have some of them, which maybe is the reason why we were having that error. Okay. And then we can run bkq to verify that it works. Yeah, it's working. Nice. So we are not going to use glfw or glm. We need a shader compiler, shader C. Okay, we got a shader compiler for us. And this is only for C++. Can ignore all of this, we can ignore it. This is for Mac OS, so we can go to the next. So here it's explaining the base code that they use, but we're going to do it differently. Let's take a look at how do we initialize the instance. We need to fill in an application info struct and then an instance creation info. Then we can query extensions and also specify layer count to 0. Okay, so yeah, they are. Let's start from the bottom. So we need to call the create instance, and then we can pass it a pointer to create info. Let's take a look at the reference for this function. So it takes a pointer to bk instance create info. Maybe we can we will fill this later. Then for the callbacks we pass a null pointer, and it's a constant pointer, so and then we get an instance back, which we need to declare first. And I don't know what type it is. It's a pointer. They use this macro bk define handle to define bk instance and a bunch of other objects. So let's try to find this bk define handle. What are they doing? So they are creating opaque pointers, seems like to me. So can we use a pointer? Something like this. And then we need to define it. Let's see. So maybe we will define a similar macro later on, but for now, if we declare an opaque struct, similarly to what we were doing in the X11 library. Yeah. This is the way it explains in the Rostonomicon how to use opaque structs. So and then we want the actual bk instance to be a pointer to an object of that type. I'm not sure if that will work, but we're gonna try. Then we need this create instance, which as we saw takes in p create info, then it takes an allocator, and it returns a pointer to the instance as an output parameter, and also returns a result. So now we are going to get again a bunch of compiler errors because we don't have some of these types. So we need dk instance create info. We can fit it later, and we need also dk allocation callbacks. I'm gonna make stubs for them for now and see if it compiles like this. So we need to actually fill out. So we need an S type, then next, a void pointer. How? I think yeah, we have a C void in standard FFI. So we can import it. Let's see if I can get this to compile. Let's see. Okay, we get warnings about unreachable statement, an unused variable result, but other than that, it is compiling. But if I try to run this, it will crash, I think. We're doing very unsafe things. Yeah, we get an error code different than 0. So let's continue to properly define this type. So we also have flags. Can I copy all of this? Okay. This is a pointer to an array of const cars. Oops. So it's called pp layer names, and it's constant i8 something like this, maybe. Then we get enable extension count, and again an array of pointers. So now we are missing this VK structure type, the create flags, and the application info. Let's start with the application info, which is, I think, also another struct. So we can put it beneath the instance create info. We get an S type, a P next, then the P application name, constant string, and then the application version, IO32, the engine name, the engine version, and the API version. From all of these, we only are missing this one. Okay, so let's now define the BKE structure type. Let's see if I have it here. And here it is. it's another enumeration. And we already have we already need application info, instance create info, and the rest we will add them as we need them. So where are we at in terms of compiling? Yeah, on line 34 I misspelled this. I need to put the asterisk before. And then we also are missing the bk instance create flags. And this is just a type def for the type flags. So we can put it on top. And bk flags, how is it defined? It's just an I32. And I'm going to put this on top because it's going to be used by many others. So let's see if it compiles now. Error, missing, enable extension. Okay, so the only error now is that we are not filling all of this data. So let's do that. So yeah, we are going to use the same data that they are using here in the tutorial. S-type, next. Then for the application name, they are using hello triangle. We need to do a conversion to a pointer of I8. Then for the application version, I'm going to set it as 0 for now. Engine name. Here they use no engine. Okay. Oh, this is the application info. And for the API version, I'm going to set it as 0 for now, see if that works. Something like that. Let's see if that works. Missing field, enable extension counts, enable layer count. Yeah, here they are using the defaults, but we need to be explicit about it. So apart from the S type, we need the next flags, then enable layer count, enable layer names, the enabled extension count, and the extension names. We are still getting some errors. Missing field, engine version. So these are for the create info, and in the application info we have S type, P name, application name, application version, P engine name, and we miss the engine version indeed. And we cannot find BK structure type create info. Can we do something like this? Yes, finally it works. And if we run, do we crash? I think we do. Do we need to derive debug? I guess we do. So let's derive debug. and we got success. So very nice. We got our first two couple Vulkan functions working. It's not very pretty right now, but we're going to improve this later on. So I need to go for now, so thank you all for watching, and I'm going to see you next time. Bye.